As in this video, I wanted to talk about what some of the issues, or one of the issues, that you can run into when you're taking the inverse of a function. So this will require an understanding of domain and range, so if you haven't already done that, you might want to do some review. There are lots of websites like Khan Academy that you can go to learn about domain and range. I recommend you go there if you do not know what a domain and a range are yet. Okay, so this problem involves domain and range. That's why I wanted you guys to have your domain and range knowledge ready. Okay, so let's get right into the problem. And with this problem, in order to understand it, we're going to look at an example. So let's say we have our function, and we want to take the inverse of this function later on. But our function is y equals x squared. Okay? All right, so not too bad, right? Now what's our domain going to be? Well, we know that x can basically be anything, right? Because a negative number, you can still square it. There aren't any limitations. So we would say negative number. So it can be negative or positive, but we know that it has to be a real number. So you would just say x has to be a member of the reals. Okay. Now what's our range? Well, y can actually only be positive, because even if x is negative, it will output a positive, because a negative number times a negative number is going to be positive. So y has to be greater than or equal to 0, and y also has to be a member of the reals. Okay. What about this inverse function? So let's say we take the inverse of this function. Now, if you remember from last video, there's a certain set of steps that you have to go through in order to get the inverse, but I'm not going to go through these because we're just talking about the issue that you might run into. So what you get is y equals the square root of x. That's our end result. That's going to be the inverse function. Okay, what's the domain of this going to be? Well, x can only be greater than or equal to 0, right? Because you can't take the square root of a negative number. And also, x is a member of the reals. Okay, what's our range going to be? Well, our range, actually, when we have a square root function, we always assume that y is going to be positive. Okay? And why do we do that? Well, I'll explain in a second. Well, the reason is because sometimes when you input a number, so let's say we input 4, if we didn't write in our range that y was going to be greater than or equal to 0, we could get a negative 2 or a 2, okay? So this just can't happen, right? Because when we have a function, we want to make sure that we only have one output, right? So we can only have one output per number. That's what a function is. But there's a problem here, right? Because for this function, we can actually have negative 2 input, and we can have a 4 come out, right? And we know that an inverse's job is to be able to spit out an input from an output, right? So if your regular function has negative 2 and gets a 4, your inverse should be able to have a 4 and get a negative 2. But that can't happen, right? Because we're saying that y has to be greater than or equal to 0. So we have to change this range somehow, right? And we can do that by changing the actual function. So this function is actually not the correct inverse. It doesn't work because it's just y equals the square root of x, and y is always going to be positive. But we can change that by saying y equals plus or minus square root of x. Now what does that do to our range? Well, our range is now going to be y is just a member of the reals. So y is now free to be negative. Y can be a negative number. So now, if we were to input a 4 into the square root, right? So I'm just going to write y equals plus or minus the square root of 4. That also means that y can equal negative 2 or positive 2. And that works, right? Because when we're outputting, or when we have like a 4 input, we can either get negative 2 or 2, right? Just like you can have negative 2 or 2 input and you'll get a 4. So the inverse of this function is actually not going to be an actual function. The inverse of this function is going to be what we call a relation. And a relation just means that when you have an input, if you have like one input, then your output can be multiple things. So let's just say you can have O or you can have R, okay? Or like O or T, okay? So you can have two different numbers as an output when you have your input. So as a quick recap, we just have to say plus or minus because we always assume that y is going to be greater than or equal to 0 when we have a square root function. And that doesn't work because then we wouldn't actually have the inverse relation. The inverse here wouldn't actually be the inverse of this function because if you have a 4 input, you could only get a 2. And if we can't get a negative 2, then it's not truly the inverse of this function. It has to also be able to be negative 2, which is why we have to write y equals plus or minus the square root of x. And that's our correct inverse. Now, so that's how we change our range to be something that actually works as the inverse. Okay? So the inverse is actually the inverse now. Now, that does mean that our inverse is no longer going to be a function, it's actually going to be a relation now. Because relations, basically, is when you have an input and you can get two or more types of outputs. So you can have like multiple different outputs from one input. So for example, you have an 4, you output 2 or negative 2. A function would just have something like this, where it goes like 2 will get you a 4, or negative 2 will get you a 4. You always only have one output per input. Every input only has one output, right? Now you can have two inputs that get you the same output, and it will still be a function. But you can't have two outputs for one input. Okay? That makes any sense? So that is how you take the actual relation of this. Sometimes when you're taking the relation of certain functions, you'll find that it's not an actual relation because it only accounts for some of the numbers. So for example, like we just did, in this case, the equation that we got from doing our steps got you y equals the square root of x. And that is not actually your inverse equation. It would have to be y equals the plus or minus square root of x. Because this equation right over here would give you certain things like this, where 4 gets you 2. Or like 16 would get you 4. Or 25 gets you 5. When really, we want our inverse to do this. 25 gets you negative 5 or positive 5, right? So that's what we have to do. We have to say plus or minus in this case. Now there are other types of functions, types of equations that you might run into that will also make this problem arise, right? Like logarithms can also have this sort of problem. But we're not going to get into that right now. So this is a certain issue that you can run into when you're finding the inverse. You always have to be very careful. You have to double check about the domain and the range, because sometimes the range of the function that you get will actually not meet an inverse expectations. It will make it so that your inverse does not actually work for your function. For example, what we just did here, y equals the square root of x, doesn't work. It has to be y equals plus or minus the square root of x. That pretty much wraps up this video. Thank you.